Hi, so we're going to go through formal charges very quickly. Now, the first example that we're going to talk about is CH2O. And in order to get the formal charges and a good Lewis dot structure for this molecule right here, what you have to do is you have to first start out with the atomic Lewis dots. And I've drawn carbon here with 4 electrons around it. And I've drawn oxygen here with 6 electrons around it. And I've drawn 2 hydrogen atoms here. And the reason why this is important is you want to figure out how many valence electrons you have to play with. If we add up all of these valence electrons, we realize that we have 12 total electrons to play with. Now, we next have to guess at the central atom. Good guess, carbon, low electronegativity. And we can start making connections from that central atom to the peripheral atoms. And then we'll see very quickly that carbon needs more electrons around it. And so we're going to make a guess that maybe carbon and oxygen have a second bond, a double bond. And now the carbon looks good. It's got an octet around it. Now we have to make sure that we use all 12 electrons, though. And in order to do that, we can simply add some lone pairs around the oxygen. And we see that we've got 4 bonded pairs of electrons, which is 8 electrons, plus 2 lone pairs, which is another 4. So we see that we've used up all 12 electrons, which is great. The oxygen has an octet. The carbon has an octet. So we're in good shape. Now, the last thing that we want to check on is the formal charges of the atoms. And so to do that, we cut each bond in half, and we assign ownership of these bonds. Now, carbon owns 1 electron from each of these half bonds. Okay, so that's 4 electrons for carbon in this bonded structure, which is great because the atomic version of carbon had 4 electrons to start with. Carbon in the bonded form has neither an excess nor a deficiency of electrons, so we would say that there's no excess of charge, and so the formal charge for carbon equals 0. Oxygen's got 6 electrons in this bonded form. That is equivalent to the 6 electrons from the atomic oxygen, and so similarly for oxygen, we'd say that the formal charge is 0 plus. Hydrogen also has a 0 plus formal charge. Bf4 minus is an anion. If we add up all of the electrons, we get 3 from boron, plus 1 for the negative charge, plus 4 times 7 for each of the fluorines. And that gives us 32 electrons. Now, the least electronegative element here is boron. And so if we start using boron as our central atom, that's a great way to fill up the octet for boron. And I'm sorry, that fluorine's very ugly, so we'll just draw a new fluorine right here. Okay, now each fluorine has 3 lone pairs around it. And if we add it up, we'll see that we're using all 32 electrons. If we cut each bond in half to figure out the formal charges, we see that the boron here has 4 electrons. The fluorine has 7 electrons. Now, for fluorine, the 7 electrons in the bonded structure is the same as what we had here for the free atom. And so for fluorine, the formal charge is 0. But for boron, the free atom only had 3 electrons. So in the bonded form, there's 1 electron more than we had as a free atom, 1 extra negative charge. And so we would say that the formal charge is minus 1 for the boron. Now, this is great because the sum of the formal charges should equal the ionic charge, which in this case is minus 1. And we have minus 1 for boron, 0 for each of the fluorines. And so this checks out. So this Lewis dot structure is great. Boron has an octet, even though it has a negative 1 formal charge. That's really the best that we can do because the anion has to have a formal charge somewhere.